and welcome. Today we're going to look at multiplying a binomial by a binomial. So I have two different methods that I want to demonstrate for you today. On the left side of the screen you're going to see the FOIL method, and on the right side of the screen you're going to see the box method. And so I have the same problem on both sides of the screen, and I've put them side by side for you to be able to compare. Both methods give you the same answer, and you can choose the one that makes sense to you or that you connect with the most. So on the left side of the screen, we're going to start with FOIL, and you're going to see that I've color-coded the letters of the word FOIL to kind of help us see where these items that we're multiplying together are coming from. So FOIL stands for first, outside, inside, and last. So in my two sets of parentheses, I want to multiply the first item from each set of parentheses. So this FOIL is going to be like a expanded distributive property. Everything in the first set of parentheses has to be multiplied by everything in the second set. So we're going to use this. So we're going to start with first. So I'm going to find the first value in each set of parentheses. So in this case, I have x times x, which gives me x squared. Then I go to outside. This is telling me that it wants me to pick the two values that are on the outside of my problem. So I'm going to take x times 4, and x times 4 is 4x, and since it's positive, I'm going to put plus 4x. Next, I go to inside. This wants me to take the two values that are inside of my problem. So the two most inside values, so I'm going to take 3 times x. That's 3x, and since it's positive, I'm going to put plus 3x. And then I have last. This wants me to take the last value in each set of parentheses. So in this case, 3 times 4. 3 times 4 is 12, so I'm going to put plus 12. Now that I've done that, and I've distributed those values from both sets of parentheses, I'm going to look to see if there are any terms that I can combine, any like terms. So I look here and I have an x squared. There's nothing to combine it with, so I'm just going to bring it down. Then I look here in the middle and I notice that I have a 3x and a 4x. Since those are like terms, I can combine them. So 4x plus 3x is going to give me plus 7x. And lastly, I have this 12, and I'm just going to bring it down because there is nothing to combine it with. So here is my simplified version of a binomial times a binomial. So I'm going to go over here to the right side of my screen now, and I'm going to work the exact same problem. I'm just going to use a different method. This is called the box method. So I'm going to start by listing my binomials on the side and the bottom of my box. So I'm going to start here with x plus 3. So I'm going to do x plus 3. And then on the bottom, I'm going to do x plus 4. So I've kind of lined this up the way that you might see this lined up if you've used algebra tiles. So if you've ever used algebra tiles in the past, this might look somewhat familiar to you. So I'm going to start here by multiplying each row and each column. So let's start in the bottom left-hand corner. Here you can see I'm multiplying x times x, which is going to give me x squared. So next, I'm going to move over to the box to the right of that. Here I can see that I'm multiplying x times 4, and x times 4 is going to give me 4x. So next, I'm going to move up to my top left corner. Here I can see that I'm going to be multiplying 3 times x, which will give me 3x. And that leaves me with one more block, which is my top right corner. Here I can see that I'm going to be multiplying 3 times 4, which gives me 12. So now that I've filled in all 4 boxes, I'm just going to write that out. I'm going to start with my x squared, then I have my 4x, then I have my 3x, and since those were both positive, I wrote them as plus, and finally plus 12. And I have to ask myself again, are there any terms that I can combine? So I noticed here in the middle that my x's I can combine. So I bring down an x squared. I combine 4x plus 3x, which is 7x. And then I bring down my 12. And again, you can see that this answer, this simplified answer, is the same as what we had on the left side. So either method works. So let's go through another example. All right, again, we have the same problem on the left and the right side of the screen. We're going to demonstrate FOIL on the left and then the box method on the right. So looking at FOIL, let's start with first, which is the first value in each set of parentheses. So I have x times x, which is x squared. The next thing I'm going to do are the outside values. So x times 5, which is a positive 5x, so plus 5x. Then I move on down to the inside, so I take my two middle values, which is negative 7 times x, which is negative 7x, so I'm going to write it as minus 7x. And finally, I move to the last value in each set of parentheses, which is going to be negative 7 times positive 5, and a negative times a positive is negative, so we're going to do minus 35. Once I have those parentheses distributed, I can look and see what kind of terms I can combine. So I don't have anything to put with the x squared. I bring it down. I can combine my x's. I have positive 5 and negative 7. Positive 5 and negative 7 give me negative 2x. And then I bring down my minus 35. So here is the product of those two binomials that I multiplied together. So let's move over here to the right and let's do the same thing, but let's use the box method. So I'm going to start by writing my values in. So I have x and then minus 7 and then x and plus 5. And again, I'm going to color code this to try to help us see how each row and each column is multiplied together. So starting in that bottom left corner, we have x times x, which gives us x squared. Now we move over one box to the right. Here I can see that I'm multiplying x times 5, which is 5x. Then I move up to my top left box. Here I am multiplying negative 7 times x, which is going to give me negative 7x. And finally I move over to my last box. Here I am multiplying negative 7 times positive 5, which is negative 35. So I'm going to bring each of those values down. X squared plus 5x minus 7x minus 35. And just like before, I have to look and see if there are any terms I can combine, and these here in the middle can. So I have x squared minus 2x minus 35. There is the product of multiplying those two binomials, and you can see once again that they match. So either method works.